With the naked eye, the sky might look like just a few twinkling stars. But with the right telescope, that darkness transforms into a window into the past, a time machine that lets us glimpse the early universe. From Galileo's first simple telescope to the James Webb Space Telescope, humanity has been building ever more powerful eyes on the cosmos. But how do they actually work? And how can a piece of glass or a giant mirror capture light that has traveled across the universe for billions of years? Today, we'll uncover the secrets of telescopes, how they're built, why they work, and how they've changed our understanding of the cosmos forever. Telescopes are essentially light collectors. The more light they can gather, the more we can see. There are three main types of telescopes. The first is refractor telescopes. These are the oldest kind, used by Galileo in 1609. They use glass lenses to bend and focus light, similar to a magnifying glass. The bigger the lens, the more light it can gather, which means a brighter and clearer image. Galileo's telescope was so small it could only magnify objects about 20 times. Yet with it, he discovered the moons of Jupiter, proof that not everything revolved around Earth. Number 2, reflector telescopes. Instead of lenses, they use curved mirrors. Light hits the big primary mirror, bounces to a smaller secondary mirror, and then into the eyepiece or a camera. This design is used in many of the world's largest observatories like the Gran Telescopio Canarias in Spain and even the Hubble Space Telescope. And finally, compound or catadioptric telescopes. These combine both mirrors and lenses. They're compact, versatile, and widely used for both amateur astronomy and research. Think of telescopes like buckets collecting rain. A small bucket only collects a few drops, but a giant bucket collects much more. The same is true for light. The larger the telescope's mirror or lens, the more light it gathers, and the fainter and more distant objects it can see. For instance, the Hubble Space Telescope has a 2.4-meter mirror, but James Webb Space Telescope, JWST, has an incredible 6.5-meter mirror, more than double Hubble's size, made of 18 gold-coated hexagons. That difference allows Webb to see objects billions of light years away that Hubble simply cannot detect. Here's something mind-blowing. When we look at distant objects in space, we're looking back in time. Light from the sun takes about 8 minutes to reach Earth. The closest star, Proxima Centauri, is over 4 years away in terms of light travel time. The Andromeda galaxy? It's about 2.5 million years away. That means we're seeing it as it was when early humans were just starting to use stone tools. With telescopes like Hubble and Webb, astronomers can look billions of years back, almost to the birth of the first galaxies. Telescopes don't just show us space, they reveal the universe's history. If telescopes are so powerful, why not just build them bigger and bigger on Earth? Well, there's a problem: Earth's atmosphere. The atmosphere is full of shifting air, dust, and moisture that distorts and blocks light. It's like looking at fish through rippling water. Everything looks blurry. That's why observatories are built on mountaintops, like the Keck Observatory in Hawaii, where the air is thinner and clearer. But even then, Earth's atmosphere blocks certain wavelengths, like ultraviolet and infrared light, completely. The solution? Space telescopes. By putting telescopes above the atmosphere, we get an unobstructed view of the universe. The Hubble Space Telescope transformed astronomy. At just 540 kilometers above Earth, it avoided atmospheric distortion and delivered crystal clear images. One of Hubble's most famous achievements was the Hubble Deep Field in 1995. Astronomers pointed it at a seemingly empty patch of sky no bigger than a grain of sand held at arm's length. After collecting light for 10 days, Hubble revealed thousands of galaxies hidden in the darkness. That single image changed our view of the universe forever. While Hubble mostly sees visible light, the James Webb Space Telescope, launched in 2021, specializes in infrared light. But why infrared? Because as the universe expands, the light from distant galaxies stretches into longer wavelengths, invisible to Hubble, but perfect for Webb. Webb sits 1.5 million kilometers away at a point called L2, where Earth's and the Sun's gravity balance. It carries a tennis court-sized sunshield to keep its instruments cold enough to detect faint infrared signals. In 2022, Webb released its first deep field image, revealing galaxies so distant their light had been traveling for over 13 billion years. That means Webb is peering back to when the first stars and galaxies were forming. Telescopes are more than just powerful cameras pointed at the sky. They're our time machines and our cosmic teachers. Through them, we've learned that the universe is about 13.8 billion years old, that galaxies are drifting apart, proving the universe is expanding, and that planets orbit stars far beyond our solar system. Today, more than 5,000 of these exoplanets have been discovered, and some of them could have the right conditions for life. Telescopes like the James Webb don't just show us pictures. They can actually analyze the atmospheres of these faraway worlds, looking for gases like water vapor or carbon dioxide that might hint at habitability. With each new image and discovery, telescopes reveal more about how stars are born, how galaxies evolve, and even how life itself might begin. They are the reason we know our place in the cosmos is not isolated, but part of an endless and expanding story. If you enjoyed this journey into the universe, make sure to subscribe to Versa Vista for more explorations into space, science, and the future of discovery. And let me know in the comments, what's the one place in the universe you'd point a telescope at if you could?